Page 769, lesson 12.7 is on theoretical and experimental probability. So a little bit of vocabulary to start out with here. First of all, an outcome is the result of a single trial. So for example, if we spin a wheel, as they mention in the book here, if you spin a wheel and you get a 5 would be the outcome of spinning the wheel in that case. Sample space is all of the possible outcomes, and an event is any outcome or group of outcomes. So for example, let's say we are rolling a number cube. Rolling a number cube, the sample space would be 1, 2, 3, 4, 5, or 6. Those are all different possibilities. Those are all the possibilities that we could have when we're rolling this regular number cube anyway. And then an event is an outcome or group of outcomes. So for example, an event could be rolling an even number. And then in terms of that, if we're trying to roll an even number, we can talk about the favorable outcomes. Those are outcomes that we would want to happen. So in this case, 2, 4, and 6, we're looking at our sample space and we're saying out of our sample space, out of these possibilities, which events would we want to happen, in this case, to roll an even number. Probability, sometimes abbreviated as just the letter P and then something in parentheses, tells us how likely something is to occur. So either an event could be impossible, which means the probability is 0 or 0%, kind of in the middle would be equally likely or unlikely, which would be like a 50-50 chance, 50% chance, or 0.5 chance. Certain is definitely going to happen, so probability is 1 or 100%. Most things are somewhere kind of in the middle. If something's in between, say 0% and 50%, it would be considered less likely to happen. If something's between 50% and 100%, we could consider it to be more likely to happen. So, theoretical probability, we're looking at the number of favorable outcomes over the number of possible outcomes. We can put it as a fraction, and we'll try and reduce the fractions if possible. We could also write them as percents. Theoretical probability, it's like how likely you would expect something to happen. So in the case of rolling an even number, we have 3 out of 6 favorable outcomes. We have 3 even numbers out of 6 possibilities. So we would expect 3 out of 6 times, or half the time, that we would get an even number. It doesn't mean that we're going to exactly get it half the time, but probably the more times we would roll, the closer we would get to half the time even numbers and then half the time odd numbers. So if we look at problem 1, our solar system's 8 planets in order of least to greatest distance from the sun are listed there. You will randomly draw one of the names of the planets and write a report on that planet. What is the theoretical probability you will select a planet whose distance from the sun is less than the Earth's? So these are in order from the sun, so we can see based off of that, if you're not familiar with this, Mercury and Venus are the 2 planets that are closer to the sun than the Earth. So that would be then 2 out of 8 possibilities, or 1/4 that would be closer to the sun than the Earth. So 1/4, or we could say 25% if we wanted. But again, we're mainly just going to be writing our answers as fractions. Just reduce fractions if we can. So they got it. Number 1. In problem 1, what's the theoretical probability you select a planet whose distance from the sun is greater than the Earth's? So greater than the Earth's, there would be 5 out of 8. And again, we could write that as a percent as well. If you divide 5 by 8, you should get 625 thousandths, which would be 62.5%. But again, 5/8, we'll consider that to be a sufficient answer unless they tell us otherwise. Next thing we're going to look at, it's called the complement of an event. So, complement of an event, it'd be all the outcomes in the sample space that are not in the event. So, in the case of, we said we had even numbers earlier, the complement to that would be odd numbers. And the sum of the probabilities of an event and its complement is 1. So in this case, if we're rolling a number cube, we've got 1/2 chance of an even number, 1/2 chance of an odd number, 1/2 plus 1/2 equals 1. Or another thing we could talk about with the weather. If we say there's a 30% chance of rain, the complement of that would be it's a 70% chance that it's not going to rain. Okay, again, 30% plus 70% adds up to 100%. So if you look at problem 2, in a taste test, 50 participants are randomly given a beverage to sample. There are 20 samples of drink A, 10 samples of drink B, 10 samples of drink C, 10 samples of drink D. What's the probability of a participant not getting drink A? So there's different ways you could do this. What the book's doing is they're looking at what's the probability that they will get drink A, which is 20 out of 50 or 2/5. And then from that, we know the complement would be not getting drink A. So if there's a 2 out of 5 chance that they would get drink A, that means there would be a 3 out of 5 chance of them not getting drink A. Another way we could do that is just look at the different options that are not drink A. So that's 10, 10, and 10. So that's 30 out of 50, which reduces to 3/5. Okay, so we got different options on how we could work that one out. So if you look at the got it 2, suppose a taste test is repeated with the same number of samples of drink A, but more samples of the other drinks. What happens to the probability of not drink A? Well, if we have the same number of drink A, we have more samples of other stuff, then probability of not getting drink A would increase. Probability of not getting drink A would increase because we have more drinks that are not drink A. So we've talked about theoretical probability. Now we're going to look at experimental probability. So experimental probability is based on data collected from repeated trials. Experimental probability is a probability based on what actually happened, based on an experiment. So if you look at problem 4, and to find the experimental probability, it's the number of times the event occurs over the number of times the experiment was done. So on problem 4, after receiving complaints, a skateboard manufacturer inspects 1,000 skateboards at random. They find no defects in 992 skateboards. What is the probability that a skateboard selected at random has no defects? Write the probability as a percent. So it's 992 out of 1,000 that they actually inspected and found no defects. 992 out of 1,000, we could write as a decimal as 992 thousandths. If you move your decimal over 2 spots, that would be 99.2% chance of it not having any defects. And it did say write it as a percent, so that's why we would do it that way in that case. So they got it 4. Similar idea, only 2,450 out of 2,500 have no defects. And they want this as a percent again. So 2,450 out of 2,500, if you divide that out, you should get 98 hundredths, which means 98% chance of no defects. You can use experimental probability to make predictions. Predictions aren't exact, so we'll round our answers. Anyway, a lot of cases it makes sense to round your answers to the nearest person or something anyway. So problem 5, you ask 500 randomly selected households in your town if they have a dog. Of 500 households, 197 respond they do have a dog. If your town has 24,800 households, about how many households are likely to have a dog? So what the book did here is they said there's 197 out of 500 that have a dog. They divided that out. They got 394 thousandths. And then they just said, well, let's take that, keep it as a decimal. Let's take that part of the 24,800 people, and then they just rounded it off. 9,771.2, they rounded it to 9,770. So they rounded to the nearest 10, I guess. Another way you could do this problem is you could just set this up as a proportion. We've got 197 out of 500, and we're trying to find the number out of 24,800. So if you take 24,800 divided by 500, you would get 49 6/10. So if we're going towards the variable, then we could multiply by 49 6/10 in the numerator, and we would get the same answer that they had in the book. Another way we could do this, we could say we've got 197 out of 500, and we can multiply that fraction by 24,800 over 1. Okay, so any of those 3 routes will get you the same answer. We got at 5, a manufacturer inspects 700 light bulbs and finds 692 of the light bulbs work. There are about 35,400 light bulbs in the warehouse. So about how many of the light bulbs are likely to work? All right, so a 692 out of 700. Again, you could just do this as a proportion, really. We're trying to find the number out of 35,400. So if you divide 35,400 by 700, you get like 50.571428571428, something like that. So that just keeps going. What we can do, though, if we're doing this on a calculator, just keep that number in your calculator and just say times 692, and that comes out to about 34,995.4 something. So we're just going to round that to the nearest whole number, let's say. Again, if you wanted to say about 35,000, it's a rough estimate anyway, I guess, but usually I'll just go to the nearest whole number when I'm working out a problem like that. So if we look at the lesson check, find the theoretical probability of each event when rolling a number cube. So this first one's saying, what's the probability when we roll a number cube? What's the probability of getting a 4? So think about, for a 4, there's 1 out of 6 sides on a number cube. That's a 4, generally. Okay. Again, they can make other number cubes that have different numbers on them. I've got number cubes that have zeros on them or different things like that. But generally, unless they tell us otherwise, a number cube we're going to assume has a 1, 2, 3, 4, 5, 6. Probability of less than 3. So less than 3 would be a 1 or a 2. So that'd be 2 out of 6 or a 1/3 chance. Probability of not a 3. Well, only a 1's a 3. That means 5 out of the 6 are not 3's. Not greater than 4. So not greater than 4. Let's think about our options here. Sometimes it helps to write them out. So which of these are not greater than 4? Well, 1, 2, 3, or 4 would work because 4 is not greater than itself. It's equal to it. So that's 4 out of 6 or 2/3 chance. Odds we did not talk about, so we'll skip number 5. Number 6, you toss a dart at a dartboard 500 times. You hit the bullseye 80 times. What's the experimental probability that you hit the bullseye? So it's 80 out of 500 times. We can reduce both of those by 10. That'd be 8 out of 50. If you reduce those by 2, that'd be 4 out of 25. If we wanted to take both of those, well, if you just go back to the original numbers, I guess, we could, if we wanted a percent's a number out of 100. So if you reduce both of those by 5, that would end up being 16 out of 100, which is 16%. Or again, we could go from this point to get to that as well if they asked for that. They really didn't ask, so I would probably just go with the 4 out of 25 would be fine. Number 7, the difference between theoretical probability and experimental probability. Theoretical is in theory what we think is going to happen. Experimental probability is what actually happened. So number 8, Eric calculated the probability of getting a number less than 3 when randomly choosing an integer from 1 to 10. Describe and correct his error. So we're looking for numbers less than 3, going from 1 to 10, less than 3. So less than 3 would be a 1 and a 2 would be all. So that would be a 2 out of 10 or 1/5 chance. All right, so this gives you an idea of how to work with theoretical and experimental probability. Have a good day.